Welcome each one of you to the course on digital electronic circuits. So we are going to deal with module 1. The topics in module 1 are number systems and codes. We need to study about decimal number system, binary number system, octal number system, hexadecimal number system, and how to convert between decimal to binary, binary to decimal, decimal to octal, octal to decimal, decimal to hexadecimal, hexadecimal to decimal, and octal to hexadecimal, hexadecimal to octal, as well as hexadecimal to binary conversions. So these are the conversions we need to study. Then we need to study about the different codes. The codes which are available are ASCII code, SS3 code, gray code, binary coded decimal, then error detecting codes. In error detecting codes we need to study only parity method. In parity method we have two parities. One is odd parity and second one is even parity. So we need to study about odd parity method as well as even parity method, how to check the error in a code. So basically these codes are used to communicate between a sender and a receiver. So how to generate these kind of codes that is in the second part. This is the first part, second part. Now the third part. In third part we need to deal with sign numbers. That means the algorithm of sign numbers. Then how sign numbers are represented. Then how addition and subtraction is performed using for this addition and subtraction in binary, octal or hexadecimal conversions. How that is represented. In that we need to study about fixed point and floating point. That means integer values as well as decimal values. Then the fourth topic is logic gates and universal gates. So we need to study about what is AND gate, OR gate and NOT gate. These are the basic logic gates. And for universal logic gates there are two universal gates, that is NAND gate and NOR gate. Okay. The reason to call this NAND gate and NOR gate as universal gates is that any other gate like AND or NOT can be realized using these two gates. That is why it is known as universal gates. Now we need to study about, in the fifth part, we need to study about logic families. So we need to study about transistor logic and CMOS logic. Okay. So we need to study about the internal diagram of TTL NAND gate and CMOS NOR gate, and we need to compare the performance based of CMOS and TTL logic families. Now, when I am forwarding with the lectures, the first four will be dealt initially. So then section 5 of module 1 will be dealt by the end of the subject. That means while proceeding with the subject, before module 2 we will complete only up to section 4 in module 1. That is number systems, codes, sign numbers, logic gates and universal gates. Only these ones will be covered in module 1 for the time being. Now let us start the topic. So for today the topic is number system. Number system. See, if you are looking to any number system, any type of number system, a number can be represented. A number can be represented in the following form generally. Okay. The general form of representation of a number can be written as dn, dn minus 1, dn minus 2, etc. d0 dot d minus 1, d minus 2, etc. d minus k. So this part will be the integer part, and this part will be the decimal part or fractional part. Okay. The point which differentiates between this integer and decimal part or fractional part is known as radix point. That point is known as radix point. Okay. The extreme left number is known as most significant digit, and the rightmost one is known as least significant digit. Okay. So where MSD stands for most significant digit, and LSD stands for least significant digit. Now n minus 1, n minus 2, etc. gives the position of the digit. Okay. That means that is of the integer part. Then minus 1, minus 2, etc. minus k gives the position of the digit. In fractional part. Okay. That means, for example, okay, the examples I will deal with the examples while dealing with the decimal as well as binary and hexadecimal and octal number systems. Okay. So this is the general representation of a number. Okay. So we have most significant digit, least significant digit, integer part, fractional part, and radix point. Okay. And the position of the digit in the integer part as well as fractional part. So this is how generally numbers are represented. Now coming into number system. The first definition in number system is radix or base. It is defined as number of symbols in a number system. That is known as radix or base. Now let me explain about decimal number system. In decimal number system, radix is 10. In octal number system, radix is 8. In binary number system, radix is 2. And in hexadecimal number system, radix is 16. Okay. So that means we need 10 symbols to represent a decimal number. To represent an octal number, you need 8 symbols. To represent a binary number, you need only 2 symbols. To represent a hexadecimal number, you need to have 16 symbols. Okay. That is done by radix of a number system. So basically radix means the number of symbols used in a number system. That is known as radix or base. Now let me explain about decimal number system. Decimal number system. Okay. The type of number system in which radix equal to 10 is known as decimal number system. The 10 symbols used in a decimal number system are 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. These are the 10 symbols used in a number system. Okay. Since there are 10 symbols, we will get that radix is equal to 10. No other symbol other than 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 is permitted in the decimal number system. Okay. So each symbol in a number system is generally called a digit. Okay. So that is regarding number. That means here 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 are digits. Okay. Now, coming into general representation of decimal number system. General representation of decimal number system. Any decimal numbers can be represented as dn minus 1, etc. d0 dot d minus 1, d minus 2, etc. d minus k. So how to read this number? This can be read as dn into 10 power n plus dn minus 1 into 10 power n minus 1 plus dn minus 2, so here you have d1, into 10 power n minus 2 plus etc. plus d2 into 10 square plus d1 into 10 raised to 1 plus d0 into 10 raised to 0. That represents this much is the integer part, plus d minus 1 into 10 raised to minus 1 plus d minus 2 into 10 raised to minus 2 plus etc. plus d minus k into 10 raised to minus k. Okay. Here this 10 stands for base or radix of the number system, and n stands for the position of the digit, as well as k also stands for position of the fractional part, position of the decimal part. The fractional part. Okay. So this is a general representation of a decimal number system. So I am giving an example. Of decimal number system. So first one, I can write 956.26. Here I can write it as this is 0th position, first position and second position. This is minus 1 and minus 2. So this I can write it as 9 into 10 square plus 5 into 10 power 1 plus 6 into 10 power 0 plus 2 into 10 power minus 1 plus 6 into 10 power minus 2. So this much part is the integer part. This much part consists of integer part, and this part is the decimal part or fractional part. Okay. Another example, if I am writing 237856.56789, this I can write as, so first you give the positions as 0, 1, 2, 3, 4, 5. This is minus 1, minus 2, minus 3, minus 4 and minus 5. This I can write it as 2 into 10 power 5. Here I am given the positions. Okay. 2 into 10 power 5 plus 3 into 10 power 4 plus 7 into 10 power 3 plus 8 into 10 raised to 2 plus 5 into 10 raised to 1 plus 6 into 10 raised to 0. Okay. This much gives the integer part. Now coming to fractional part, plus 5 into 10 raised to minus 1 plus 6 into 10 raised to minus 2 plus 7 into 10 raised to minus 3, 10 raised to minus 3 plus 8 into 10 raised to minus 4 plus 9 into 10 raised to minus 5. So that gives the fractional part. Okay. So I think you have understood how to represent a decimal number. So that was an introduction to decimal number system. So to summarize about decimal number system, in decimal number system we have number of digits or number of symbols, that is radix is equal to 10. The 10 symbols are 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9, and each symbol in a number system is generally called a digit. Now the general representation of a decimal number system, you can write, if I am writing a number as dn minus 1 etc. d0 decimal, that is d minus 1, d minus 2 etc. d minus k, I can write it as dn into 10 raised to n plus dn minus 1 into 10 raised to n minus 1 plus etc. d naught into 10 power 0 plus d minus 1 into 10 power minus 1 plus d minus 2 into 10 power minus 2 plus etc. into d minus k into 10 power minus k. This is the general representation of a decimal number system. So here I have given two examples. So here I can write this 956.26. This is basically a decimal number. So I can write this as 956.26 to the base 10. Base 10 means it is basically a decimal number. This also I can write it as 2378.56789 to the base 10. That means here I am writing the base or radix of the system. This is the base and this is one of the radix or base. Okay. So that was an introduction to decimal number system. Now coming into binary number system. Next kind of number system which we are going to deal with is binary number system. Binary number system. In binary number system, the number of symbols used is 2. That is radix. Radix is equal to 2. Radix is equal to 2. The two symbols which you are using here is, or two digits or two symbols which you are using, two symbols or digits which is used in binary number system is 0 and 1. Solely you are using 0 and 1 in binary number system. No other numbers are allowed to be used in binary number system. We are writing it as 0 and 1 only. Now, if you are going to the general representation of a binary number system, it does say bn minus 1, bn minus 2, etc. b naught dot b minus you can adjust b minus 1, b minus 2, etc. b minus k. Okay. So here I can expand it as bn into 2 power n, because here the radix is 2. bn into 2 power n plus bn minus 1 into 2 power n minus 1 plus etc. plus b naught into 2 power 0 plus b minus 1 into 2 power minus 1 plus b minus 2 into 2 power minus 2 plus etc. b minus k into 2 power minus k. So this is basically a binary number. This is basically a binary number, and by using this equation number 1, we can convert it into a decimal number. You can convert the binary number into a decimal number. That means with respect to the position, if you are converting a binary number, the formula is given, and we can directly get the decimal number. So I will give the example of that here also. Okay. So here I can write it as, for example, I am writing a decimal number. Sorry, a binary number. So I will show a binary number. Here I can write as a 1011.11. Okay. So this is basically a binary number, because here I am using zeros and ones only. So I can write it as base of the number is equal to 2. Now, how will you convert this binary number? Into decimal number? How will you convert this binary number into decimal number? That is the key point here. Okay. So I can write it as 1011.11. Okay. So this is the position. First I need to write the position of the number. So positions I can write it as 0, 1, 2 and 3. This is minus 1 and minus 2. Therefore the decimal equivalent of this binary number, can be written as 1 into 2 raised to 3 plus 0 into 2 square plus 1 into 2 raised to 1 plus 1 into 2 raised to 0 plus 1 into 2 raised to minus 1 plus 1 into 2 raised to minus 2. So what is 2 raised to 3? It is 8 plus 0 into 4, that is 0, plus 2 plus 1 plus 0.5 plus 0.25. So what is the answer? 8 plus 2, 10 plus 1, 11 plus 0.5 plus 0.25 is 0.75. So answer is 11.75. So I can write it as 1011.11 to the base 2 is similar to 11.75 to the base 10. So here I have explained about binary to decimal conversion. Hope you have got it. Now, how to count the binary numbers? That is the next part. How to count the binary numbers? So I will deal with the first 32 binary numbers. Okay. How to deal with this binary numbers? So binary counting. We will deal with binary counting. Okay. So I will write a column here. Decimal number and corresponding binary number. Okay. See, here I am going to use basically a 5-bit representation. Basically 5-bit representation. Okay. So I will go from, because 2 power 5 is 32. That is why I am going for this 5-bit representation. So here also I am having decimal and corresponding binary. Okay. So now I am writing the decimal numbers up to 32. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. So initially we will stop at 15. Then we will count to 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. One more is required. Decimal, binary, 25, 26, 27, 28, 29, 30, 31, and 32. This conversion I will explain. I have already explained the conversion. So I am going for 5-bit representation. So 1, 2, 3. So going to this 5-bit representation. Let me take it in another way. Okay. So here initially what we are having is 32 numbers. So in binary representation we are having 5-bit. Okay. 5-bit means, okay. Now in 5-bit representation up to 15. Yeah. Up to 15 means, yeah. So I can write it as 0. First you can write 32 numbers. So first is 16. You can write it as 32 numbers means I can write up to 31, not up to 32. I can write up to 31. Okay. So 2 power 5 is 32 means the decimal equivalent I can show up to 31, because 0 is the number which is included in the 32 numbers. Okay. So I can write it as first 16. First 16 you can write it as 0 first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Next 16 as 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That is up to 31. Okay. So now I have written 16 to 16. Now 8, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, and 8. Okay. Now comes to 4, 4. 1, 2, 3, 4. 4 zeros and 4 ones. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay. Now now comes, now 4, 4 is over. Now come to 2, 2. 0, 0. 1 second. Rub that. Okay. Now comes 2, 2. 0, 0. 1, 1, 1, 2, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1. Okay. Now you write 0, 1. Last bit. That is 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1. Okay. So this is the basic 5-bit representation. So 32 numbers means you need to take from 0 to 31. Okay. That means you can write in 5-bit combination. In 5-bit combination, you can write 12 as, okay, you can write 12 to the base 10. In 5-bit representation, you can write it as, how you can write it? That is 0 1 1 0 0. The 0 1 1 0 0 to the base 2. That's number 25 to the base 10. How you can write it? 25 to the base 10. You can write it as 1 1 0 1. 1 1 0 1 to the base 2. So I think you have understood with binary counting as well as decimal counting. So here I am stopping with this binary counting techniques. So to have a recap about this binary number, in binary number system, the number of symbols used is 2. That means the radix is 2. The two symbols which is used are 0 and 1. The general representation of a binary number is Bn. So here Bn, Bn minus 1, Bn minus 2, etc. B naught dot. This is the radix point. Radix point. B dot B minus 1, B minus 2, etc. B minus k. So if you are converting that binary number to decimal, I can use this formula: Bn into 2 power n plus Bn minus 1 into 2 power n minus 1, etc. B naught into 2 power 0 plus B minus 1 into 2 power minus 1 plus B minus 1 into 2 power minus 2 plus etc. B minus k into 2 power minus k. Okay. In decimal number system, instead of this 2, we have 10 because the base is 10. But here the base is equal to 2. Therefore, we are using the number 2. Now coming to a conversion of this binary number to decimal number. So if I am having a number like 1011.11, so here I am using only two symbols, that is 1 and 0. So this is basically a binary number. Okay. Now how will you convert it into a decimal number? So 1011.11. First you assign the positions. So like 0 1 2 3. So this is the radix point. And after the radix point, you can adjust minus 1 and minus 2. So the decimal equivalent I can adjust 1 into 2 power 3 plus 0 into 2 square plus 1 into 2 power 1 plus 1 into 2 power 0 plus 1 into 2 power minus 1 plus 1 into 2 power minus 2. So you get it as 8 plus 0 plus 2 plus 1 plus 0.5 plus 0.25, that gives 11.75. That means here here we are using two symbols, and here we are getting the values of the decimal part also. So I can write it as 1011.11 to the base 2 is similar to 11.75 in the base 10. That means this is binary and this is binary and this is the decimal part. Okay. Now to have a brief about the binary counting, I am taking an example of a 5-bit representation. In 5-bit representation, I have 2 power 5. 2 power 5 means 32. That means I can count from 0 to 31. So I am going with the 5-bit representation, and I have shown the 5-bit representation of the numbers ranging from 0 to 31 in decimal and the corresponding binary number. Okay. And with that, I am ending with this lecture number 1. Okay. So to conclude with lecture number 1, what we have dealt with is we have started with what is done by the 3 topics which is dealt in this lecture are: first one, what is basically a number system. In number system we have discussed about radix. Okay. Then we have discussed about decimal number system. Third point, we have discussed about binary number system. Okay. And also we have dealt with how to convert binary to decimal. Okay. And we have also dealt with, in binary number system, we have also dealt with binary counting. binary counting. So that is an overview of this lecture. So in the next lecture we will be dealing with octal and hexadecimal number systems. And thank you, and seeking your attention in the next lecture also. Thank you.